In this problem we have an amateur plumber unable to loosen a pipe fitting, slips a piece of scrap pipe, called a cheater, and over the handle of his wrench. Then he applies the full weight of 900 newtons to the end of the cheater by standing on it. The distance from the center of the fitting to the point where the weight acts is 0.80 meters, and the wrench handle and the cheater make an angle of 19 degrees with the horizontal. They're asking us to find the magnitude and the direction of the torque of his weight about the center of the pipe fitting. So here's the graph that representing the question. It's giving us that the angle is 19. So therefore, the angle that is below the foot of the plumber, this angle right here is going to be 109. And that is because the force, the 900 newtons, is perpendicular as it crosses this line and this one going downwards. So we can say that this is a 90 degrees angle, and since this is 19, to get to 90 degrees, this is 71. So up here we have a straight line, and it's gonna be 180 degrees minus the 71, which is give us the 109 degrees. Up here we have the radius. So to find the magnitude and the direction of the torque, first we need to find the length on the moment arm, which is located down here. You could say it's like the base. So that is going to be equal to the radius on top times the side that's here, which is could be the sine of 71 or either the sine of 109 degrees. Or it could also be the cosine of this angle 19. So as we plug that in the calculator, we get the length being 0.76 meters. Now, to find the torque, now that we have the length, we can use this formula, force times length, and that's going to be equal to 900 newtons multiplied by 0.76. And that should give us a torque of 680 newtons per meter. Another way that we could have done this problem is by using a distinct formula, which goes like this. The torque is equal to the radius times the force times the angle between the radius and the force. In this case, it was going to be the sine of the angle 109. So we got the radius 0.80 times the force 900 times the sine of 109 degrees. And that should give us the same answer as we got the first place, 680 newtons per meters. So in this case we have a cable that is wrapped several times around a uniform solid cylinder with a diameter of 0.12 meters and a mass of 50 kilos. And this can rotate freely about this axis. And the cable is pulled in by a force with magnitude 9.0 newtons, and it says the following. Assuming that the cable unwinds without stretching or slipping, we have to find the magnitude of the acceleration. So the 9 newtons is the force that is being pulled. Then there's another force that is going in this direction that will balance it. Will balance the weight that is going down, the force of the gravity, and the force that's being pulled. One thing we should also notice is that the radius 0.060 meters is going to be the same for the moment arm length because it's perpendicular. Now to find the angular acceleration, first we need the torque and inertia. So for the torque, we just use the equation F times L because we have these values, and that's going to be 9 newtons times 0.060 meters, which would be 0.54 newtons per meter. In regards to the inertia, we use the equation 1/2 mass times radius squared because we also have those values in the problem. It's going to be 1/2 times 50 times 0.060 meters squared, and that should give us 0.090 kilograms per meter squared. Now that we have both the torque and the moment of inertia, we can now find the angular acceleration. So we will just divide the torque by the moment of inertia, or 0.54 newtons per meters divided by 0.090 kilograms per meter squared. So the angular acceleration would be this right here, 6 radians per second square. Now why did we find the angular acceleration? Because we need to find the acceleration and the magnitude. So that would just be the radius and the angular acceleration, or 0.060 times 6 radians per second square, and that should give us 0.36 meters per second square as a final answer.